Okay, for our lesson today, first of all, let's talk about the assignment. The assignment that was due today was 105 to 108. The assignment that you are doing for today is this one, and this is going to be due on Monday, which is the 27th. So if you have your packet out, go ahead and write 1027 there, and please do these problems for the next assignment. A few of you already did those problems, and I talked to you about how we're going to trade, and you're going to do the ones from before, okay? Just know what your assignment is. Let's talk through our learning target for today. We did these a little out of order. So we did Pythagorean theorem last class. Today we are doing the triangle inequality theorem. And here's your target for today. There are rules about what kind of sides can make a triangle and what kind of sides cannot make a triangle. My goal for you today is that when you walk out of here, if I say, I'm going to try and build a triangle and these are the three sides I'm going to try and use, I want you to predict for me, yes, you're going to be able to build a triangle out of those three sides, or no, there's no way you're going to be able to build a triangle out of those three sides. That's our goal for today. Okay? So understanding the triangle inequality theorem means that you know if you get three sides, you can say yes or no, you're going to be able to build a triangle. In order to do that, we are going to test it by building some triangles. So the materials that you're going to need a pair of scissors, and you're going to need a ruler, and your ruler needs to have centimeters on it. If you have your own ruler with centimeters on it, that's fine. It needs to go up to 14. No, it needs to go up to 12. Actually, it needs to go up to 12. So I've got a little tiny baby ruler here someplace. It's just not big enough. And then you're going to need 3 straws. All right, a ruler, scissors, and 3 straws. Let me tell you where everything is, and then you and your partner can get this done. The scissors are over there by the window. You guys see them? The rulers are in the back of the room in a wooden box. They're underneath the tissues. Again, not all of them have centimeters on it. Make sure that you grab a ruler that has centimeters on it. And the straws are over here on my desk. So come see me and I'll hand you your 3 straws. All right, go get your materials. 1, 2, 3, go. Okay. Here's what I need you to do with your scratch paper. We are going to draw 5 line segments on your scratch paper. The first one is going to be 4 centimeters long. So write down the number 4, and then right next to it, grab your ruler and draw me a line segment that is 4 centimeters long. Try to be as precise as you can when you do this. All right. And then you're going to do, right underneath that or next to it or whatever, you're going to do another one that's 6 centimeters long, and then 8 centimeters long. Anybody want to guess what's next? 10 centimeters long, and one last one that's going to be 12 centimeters long. Okay, so we're just drawing line segments using our ruler that are each of these lengths. And again, try to be as precise as you can while you're doing this. The more accurate we can be, the better our final product is going to be. While you're doing this, I want to remind you guys how amazing our custodial staff is here at Ferndale High School. They do such a great job of keeping this place clean and tidy. They deserve our respect. That one is too long. They deserve our respect, and the way we're going to show them our respect today is we're going to make sure that all of the scraps from what we're about to do end up in the trash can and not on the floor, okay? Then this is going to be especially hard to do because these stirs are dark colored and the carpet is dark colored and they're going to blend in really easily. So do your best to try and keep them on your desk and get them thrown away in the trash can, not the recycle bins at the end of the period. These don't recycle, I don't think. They're just going to stick to the sides anyways. Okay? Okay, so now comes the fun part. We are going to cut. Now hang on before you start on this, because you only got 3 straws, and I'm not giving you another one if you screw this up. Your group has 3. Each group has 3. If you've got more than that, then you got more than you need. Okay? You are going to cut, you and your group, you and your partner are going to cut me 5 pieces of straws that have these lengths. Now be strategic about this because you only have 3 straws to do it from. Okay? So if you are going to do a 4 centimeter piece, what would be smart to do out of the same straw that you do your 4 centimeter one with? Can you fit the 4 and the 12 out of the same straw? If you can, that would be a smart thing to do. If you can fit the 4 and the 10 out of the same one, that would be smart to do. If you do the 4 and the 6, I don't think you're going to get anything else out of that. Okay, so be strategic about it. Decide how you're going to do this, but cut those straws. And again, try and be as accurate as you can. I'm actually going to use a pencil to mark on the straw and then pick the straw up and cut it because I find it easier to cut if it's not on the paper. And a pencil will make enough of a mark on there that I can see once I pick it up. That's pretty good. What's that? Yes, it needs to be as exact as possible. Of course, it can never be 100% exact, but I need you guys to be very careful because this isn't going to work if we're not pretty close. Okay, so I just want to remind you of our learning target for today. Our learning target is to understand the triangle inequality theorem. And the triangle inequality theorem is just a rule that says if you've got 3 sides, can we make a triangle out of it, yes or no? So I'm going to give you some sides, and I want you to grab those ones. Now, it should be easy to just kind of hold them up to your paper and see which ones I'm talking about. But for the first one, we're going to do 4, 6, and 8. So grab your 4 centimeter, 6 centimeter, and 8 centimeter straw. Pull them out to the side and see if you can make a triangle out of them. They kind of roll around a little bit, so be patient with them. You got 2 people, so if one person needs to hold something in place for a moment, go ahead and do that. 4, 6, and 8. Did it work? Mine worked. Try, was everybody able to make one? Does it look similar to mine? Maybe rotated or reflected or translated? You can't see mine? It's down at the bottom of the screen there. Oh, my computer's in the way. Is this better? Okay. All right, could you try 6, 8, and 10, please? 6, 8, and 10. Let's see, here's my 8. Here's my 6. I don't need a 4 right now. Does 6, 8, 10 work? I heard some interesting comments from a couple different groups as you were putting this one together. I had a claim that this is a special triangle. Is it a special triangle? You think it's a right triangle? If it's a right triangle, then the Pythagorean theorem should hold true. Is it true that 6 squared plus 8 squared is the same as 10 squared? What's 6 squared? 36. Hold that in your brain for a second. What's 8 squared? 64. So 36 plus 64 is 100. And that's what 10 squared is, right? So a squared plus b squared equals c squared. That only works with right triangles. All right, so we made a triangle. Wonderful. Nicely done, guys. All right, your next task, 4 centimeters, 6 centimeters, and 12 centimeters. 4, 6, and 12, please. Make me a triangle that has sides of 4 centimeters, 6 centimeters, and 12 centimeters. Four centimeters, 6 centimeters, and 12 centimeters. Trick question? No trick questions. Filthy? That's not very nice. Yeah. That's the side of the triangle. Okay, I want to remind you of our learning target for today. Our learning target for today is the triangle inequality theorem, which is a rule that determines whether or not you can make a triangle out of 3 given sides. Can we create a triangle out of the sides 4, 6, and 12? No. Why not? If I put that right there and this right here, is there any way I can ever make these two, the 4 and the 6, meet up with each other? They're not going to meet. There's no way they can meet. They're not long enough. Can you find me another combination of sides that, or of triangles that would not work from these 5? Find me something else that would not work. We saw 2 examples that would work. We just saw one example that doesn't work. Can you find me another one that does not work? 4, 6, 8 we tried and it worked. What are you trying? What are your 3 sides? 4, 6, and 10. One of your groups has suggested 4, 6, and 10. Has anybody else tried this yet? We're trying to decide whether this makes a triangle or not. 4, 6, and 10. Is that a triangle? Now, if I measured everything perfectly, I don't think it is either. If I measured everything perfectly, I'm going to have 2 sides that are going to be the exact same side as the other one. In order for them to stretch and meet in the middle, they've got to be like fully collapsed onto the other side. A triangle has to have some area inside of it. That's not a triangle. This is kind of 3 line segments overlapping each other. Now, hey guys, let me get your attention, please. What if I made this 6 a tiny little bit longer, if it was like 6.1 instead? That would be enough to bump it out, and it would be a very skinny triangle, a very narrow triangle, but it's still a triangle. So it's possible if one of either the 4 or the 6 was slightly longer, we could make a triangle, but 4 and 6 and 10 does not work. Did anybody find anything else that did not work? What did you find? 4, 10, and 12. So I'm going to go with my 4, my 10, and my 12. 4, 10, and 12. I'm able to make a triangle with 4, 10, and 12. So that's a good example of one that we can make a triangle with. It's not a right triangle. It's a scalene triangle. It's an obtuse triangle, looks like. 4, 10, and 12. Any others you found that do not work? 4, 8, and 12. So here's my 4, here's my 8, and my 12. I'm going to try and make a triangle out of this. Oh, this is going to be another one of those skinny ones. No, it's not long enough. So 4, 8, and 12 doesn't work either. So we found some stuff that works. We found some stuff that doesn't work. Let's make a list of triangles and non-triangles. I'm going to list the sides that we tried. The first one that we tried was 4, 6, and 8, and that worked okay. We tried 6, 8, and 12, and that was fine. what else did we try that worked? The next one we tried, the one that I told you to do next was 4. No. Did we do 6, 8, 12? No, we did 6, 8, 10. We did 6, 8, 10. I don't think we tried 6, 8, 12. Oh, you had us try 6, 8, 12 a moment ago. And that worked. Should have been writing these down as we went. Non-triangles. The first one I gave you that did not make a triangle was 4, 6, 12. You guys also found that 4, 8, 12 didn't work and 4, 6, 10 didn't work. There's a rule. You give me 3 numbers and I can tell you whether or not those 3 numbers are going to make a triangle without cutting out straws and trying it. I'm curious if you guys can find a pattern here. What is special about these groups of numbers that these things have that these groups of numbers do not have? I want everybody to think about it for a second. I will promise I will call on you. I can tell it's dying to get out. Can you guys think about for a minute, see if you can figure out what is the numerical rule? If I gave you something with bigger numbers, sorry, I'm looking for scratch paper. If I gave you something like 11, 25, and 31, would you be able to make a triangle out of that? And that's our goal for today. So using the experiments that we've tried so far, see if you can come up with a rule. What do these sets of numbers have that these ones did not? Talk it over with your neighbors. We'll come back together in 2 minutes. I've heard some great discussions, and I want to call on some folks that are willing to share their thoughts with the class. Guys, this is always a pretty bold and brave thing to do, so we're going to be respectful. If somebody says something you don't agree with it, that's okay. You can respectfully give a different opinion, but don't be mean or anything like that. Not that I have to tell this class that. All right, who would like to make a conjecture? In math, a conjecture is an educated guess. We think it's probably right. Maybe you want to test it a little bit. All right, I got a volunteer here. Thank you for being bold. All right, if you couldn't hear that, the 2 smaller numbers have to add up to be bigger than the biggest number. Let's see if that works for our test case so far. So if I look at these ones, my 2 smaller numbers are 4 and 6, and if I add them up, they come up to 10, which is bigger than 8. So that is a triangle. So I got 6 and 8 makes 14, which is bigger than 10. 6 and 8 makes 14, which is bigger than 12. Okay. Now you said they have to be bigger than the other one. So let's see if the other ones fail this. So 4 plus 6 is 10, which is smaller than 12. So that would fail. That would fail your test. I'm not saying it's the right test, but it would fail your test. 4 plus 8 is equal to 12. It's not bigger than 12. It's equal to 12. So that doesn't make a triangle. And 4 plus 6 equals 10. Not bigger than, equals to, so does not make a triangle. Because you said it has to be bigger than. What do you guys think? Is that going to work for any 3 numbers? Did anybody have something similar? I heard somebody say something that was kind of the reverse of it. Instead of saying that the 2 small sides have to be bigger than the third side, someone said, I can't remember who it was, someone said if the 2 small sides add up to something smaller than the third side, then it fails. So your rule was basically the same thing. But we got to make one small change though, because what if it's equal to? So did you say smaller than or equal to? Okay. So now let's think about it that way, because sometimes it's easier to conceptualize something the backwards way, like you've said it. Because if I said that I had a triangle, I'm going to go ahead and test this one. 31, or 11, 25, and 31. The big one is 31. Is it possible for me to have 2 sides, 11 and 25, that create my third side for this triangle, based off of that rule? The 2 small sides add up to 36. 36 is bigger than this, so would that be possible? Yes. What if I change this 25 to a 15? Is that going to work? So the 11 and the 15 are not long enough, even if I put them, even if I stretch them straight across, the 11 and the 15 are not going to be long enough to make up the 31, right? Because 11 and 15 still leaves us how much left over of a gap in here? 11 and 15 is 26. We would still have a 5 centimeter gap, even if those two sides were completely flat against the third side. There's no way you could make a triangle out of that. If I change it so that it's 11 and 20, what happens in that case? Well, now, the 11 and the 20 are going to meet up, but they're not long enough to create a triangle. Those lines are going to be just stacked on top of each other like those straws were a minute ago. So that's the rule. The rule is that the two smaller sides have to add up to be something that's bigger than the third side in order to pass. Or to fail, the two small sides have to add up to something that's smaller than or equal to the third side. Could I get you guys to write down some notes on that inside of your packet, please? Can you guys please find this in your packet? It's kind of halfway down the bottom of a page. It doesn't start at the top of a page. It's on the same page where we did some areas previously. It's just a couple pages from the end of the packet. Knowing what we know right now, before we write this down, could I get you guys to do these three problems? Yes or no? Can you form a triangle? So look at those three values and ask yourself, yes or no, can I form a triangle out of these three sides? Okay, and maybe illustrate with some, put some reasoning there, put some thought bubble there that helps you understand why. And then once you've got those four problems done, go ahead and write down a rule. A general rule that's going to work for any amount of sides, or any three sides. All right, I want you guys to help me out here. Pretend like I've never seen this before and help me with this first one. Can I make a triangle out of these three sides? No? Can you explain to me why? So what am I looking at? The 3 and the 5. I'm looking at the 3 and the 5. And what did you do in your head with that 3 and the 5? You said 3 plus 5 equals 8. This is kind of going on inside. This is my thought bubble for that. And 8 is less than 10. So that means no, right? We cannot make a triangle out of that. All right, what about this next one? So it looked like you went to the small sides this time. So you're going to look at the small sides this time. 4 and 9 is, so my thought bubble this time says 4 plus 9 is 12. 13 maybe. 4 plus 9 is 13. Thank you for that help. And what do we know about 13 compared to 12? It's bigger. So the answer is yes. Bigger is good. How about this one? My two small sides are 2 and 4. So in my thought bubble, I'm doing 2 plus 4 is 6. And I'm looking at that 6 and I'm looking at that 5 and the 6 is bigger. So what's that tell me? Yes, that makes a triangle. We can totally make a triangle out of those because the two small sides add up to something bigger. And then the last one, and this is an important one too. This time on my thought bubble, I'm doing 3 plus 5 is 8. And I compare that 8 to the third side, and it's not bigger, it's not smaller, it's the same, it's equal. Is that good or bad? That's bad. We cannot make a triangle if they add up and it's exactly the same. All right, what happens, I did not put this in the packet, but what happens if you get to a test problem and they give you a problem that says 3, 11, and 9. Ooh, that's tricky, isn't it? What would you be adding up in this case? 3 and 11? No. We have to add the 3 and the 9. But do you see how somebody might be tempted to say, oh, I'm going to add the 3 plus the 11, that's 14, 9's too small, that doesn't work, right? You got to add the two small ones, yeah. So if we did 3 plus 9, that's 12, and that does work. So it's got to be it's not the first two compared to the last one, it's the two smallest compared to the biggest. And I kind of wish that I hadn't had all of these examples be in numerical order for that reason, right? Okay, so that's important. You might want to make a note of that. So again, I asked you to write in your own words, what is the triangle inequality theorem? Go ahead and write it down. I'm not going to write words here for you to copy. So if that's your strategy, if you're waiting for me right now, stop. If you understood these examples, then you should be able to write some words down there. If you didn't understand these examples, get my attention in a moment and I can help you. Number 102, this is kind of the most challenging part of our lesson for today. Can you pick your head up, please? Thank you. We've got a triangle, and they drew it for us, but imagine that this triangle is flexible. It's made out of rubber bands, okay? My question to you is, what is the absolute smallest that I can make this third side and still have it be a triangle? And what is the absolute biggest that I can make that third side and still have it be a triangle? So I'm hearing a couple different answers. Are you willing to give your reasoning for it? Nope. Okay. Well, thank you for your input all the same. Yeah, go ahead. Okay, so 13 plus 19 add up to 32, right? And we need these two things to add up to something bigger than this, right? So this cannot be any bigger than 32, agreed? If this was bigger than 32, then 13 and 19 would not add up to enough to cover it. So it can't be any bigger than 32. Could it be equal to 32? No, because the 13 and the 19, the two small sides cannot add up to equal this either. So, but it could be a tiny bit less than 32, and that would be okay, right? 31.99 would be fine. It would still make a tiny little triangle, a very narrow triangle. So I'm going to say that x, let's call it x for right now. I'm going to say that x has to be less than 32. Not less than or equal to, but less than. Agreed? That's if x is the big side. What if x is one of the small sides? If x is one of the small sides, then what would the big side be? If x is one of the small sides, then the big side would be 19. What's the smallest x could be so that it wouldn't break that triangle? So if these two added up to be equal to 19, what would x be? X would be 6 to make it equal, which wouldn't work, right? So x can't be 6. It would have to be a little bit bigger than 6, right? Anything that's bigger than 6 would work. So x would have to be greater than 6. My final answer to this, and I don't know that you would have seen this in your Algebra 1 class, but this will come up a bunch in some higher level math classes. This is called a double inequality. When x is allowed to be in between two numbers, we write something that looks like this. X is bigger than 6, smaller than 32. This is called a double inequality because it includes both of these things in it. X is bigger than 6, right? Alligator's eating the X. X is smaller than 32. Alligator's eating the 32. We stick them together, we get this. So this would be our final answer. So x could be anywhere from 32 to 6. And how do we get those two numbers? We got the 32 by adding the 13 and 19. Where did the 6 come from again? We subtracted them. Yeah, so the 6 came from doing 19 minus 13. There's my little thought bubble for the 6. And the 32 came from 13 plus 19. There's my little thought bubble there. Could you guys use a similar logic to give me a range of values for x, for our missing sides for this one and for this one? If these triangles were made out of rubber bands, or at least if that missing side was made out of a rubber band, what's the shortest we could make that side, and what's the longest we could make that side? I'm not looking for answers right now. Just write them down. Sure, question?
I'm not really sure how to do C.
Ooh, well, I think you're going to have, these are going to have A's and C's in them.
Okay.
Yeah, this is X. This is X. So they're not going to be numbers. It's kind of, it's like, what do? We added for the big one and we subtracted for the small one, right? I'm going to put some answers up on the screen here for part B so that you can check. But if you're not quite done, don't look up here until you've got at least a guess written down. Oops, there is no B. What am I doing? Can somebody help me out with this blank right here? This one's A plus C. Whatever A and C are, you add them together. That's easy. What am I gonna put here? A minus C, but isn't it possible that A minus C could come out to be negative? The bigger one minus the smaller one. Is there some kind of mathematical trick we can do to make sure this always comes out positive? Like, for example, if we had 14 and 15, if I do 14 minus 15, I get negative 1. If I do 15 minus 14, I get positive 1. That's always going to be the case, right? If I flip them, I'm just going to get the negative of the other thing. What is the mathematical trick that we have that ensures that whatever we get, it's always positive? What is that thing called that always makes things positive? Takes negatives and turns them positive, keeps positives the same. Those things, yes, those things. What are those things called? Starts with an A. That's it. That's it. Nice. Absolute value. So we could do A minus C or C minus A. It doesn't really matter. But if you put an absolute value around it, that means you're always going to get the positive version of that. Even if it ends up being negative, the absolute value will force it to become positive. All right, folks. So our learning target for today was, if I give you a list of 3 numbers, can you tell me whether those 3 numbers are going to make a triangle? So right now, test yourself and see if you can do this. If I gave you 13.7, 11.6, and let's see here, 5.8, can we make a triangle out of those 3? Yes? For sure? Because why? These are my 2 small ones. We add them up. It's definitely going to end up bigger than this. All right. You guys did awesome. Feel free to, not feel free, I insist and invite you to use the rest of our time